is the angle-side-angle theorem? The angle-side-angle theorem states that two triangles are congruent if any two angles in their included side are equal in both triangles. This theorem is important to geometry because it assists us in proving triangles to be congruent. Step 1 is to determine what you are trying to prove. We are trying to get angle MLO to equal angle MNO. If we are able to prove these two triangles congruent, then we can prove these two angles equal by the definition of congruency. Step 2. We're going to begin writing our statements and proofs. First, label your givens. Now, to make things easier, I'm going to provide the angles with numbers, and that's how we will refer to them. Angle LMO will be angle 1. Angle NMO will be angle 2. Angle LOM will be angle 3. Angle NOM will be angle 4. Angle MLO will be 5. And angle MNO will be 6. So, our second given is that angle LOM equals angle NOM, but we renamed these. Angle LOM is angle 3 and angle NOM is angle 4. So, angle 3 equals angle 4. Our third step is going to have to do something with the bisection that was given to us. Because OM bisects angle LMN, that means that angle 1 and angle 2 are equal. This is because to bisect means to divide into two equal parts. The reason for this step is the definition of bisection. Now we have two pairs of equal angles, angles 1 and 2 and 3 and 4. The last thing we need is to be able to prove these triangles congruent is the side between the two angles, the included side. Look at the image given. These two triangles have a shared side, and it is between the two pairs of angles, therefore making it the included side. The step for this is MO equals MO, and the reason is identity, because MO equals itself. We have all the requirements to prove these triangles congruent by the ASA theorem. We have the two pairs of equal angles as well as the included side. Now we are able to say that triangle LMO is equal to triangle NMO. The reason for this is the angle-side-angle theorem. Because we have proved these triangles congruent by the ASA theorem, we can now say all the other components of the triangles that are congruent. Because we've proved these, we know that side ML is equal to side MN. We also know that side LO equals side ON. And we also know that angle 5 equals angle 6. We have successfully proven the proof. Now you have to state this. The reason for this is the definition of congruency because we proved these two triangles congruent. What is the alternate interior angle theorem? This theorem states that if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. A transversal is a line that crosses or passes through two other lines. Where are alternate interior angles? The angles that are formed on opposite sides of the transversal and in between the parallel lines are the interior angles. To find these angles, you may trace a z. Therefore, angle 1 and angle 2 would be equal. Therefore, angle 3 and angle 4 would be equal. This theorem is important because it helps us find missing angle measurements. In a proof, the reason is written as such: parallel lines, therefore alternate interior angles congruent. We are given parallel lines cut by a transversal. The transversal line is C. Follow the z's to find the alternate interior angles. Here we have angle x and angle z equal, and a backward z leads us to trace over angle w and angle y, meaning these are equal. Now, because angle y and angle w are equal alternate interior angles, angle y also equals 58 degrees. We also know that angle y plus angle z equals 180 because of definition of a straight angle. Now, because we know angle y equals 58 degrees, we may substitute angle y for 50 degrees. Now, we can solve algebraically. Now we have that angle z equals 122 degrees. And because angle x and angle z are equal, because angle z is 122 degrees, we also know that x is 122 degrees. What is the angle-angle theorem? If two pairs of corresponding angles are congruent, then the triangles are similar. This is important to geometry so that we may prove triangles to be similar, therefore finding missing sides. In order to figure out a missing side, x, it is imperative we prove the two apparent triangles to be similar. We need two pairs of corresponding angles to be equal. We have vertical angles and parallel lines. For vertical angles, we have right here this little bow tie. So we can name these angles 1 and 2. And those are congruent. Also, following from parallel lines but 4 alternate interior angles, we can trace z. So here, this lands us here, angle D equal to angle B. So we can call this 3 and this 4. Now that we have two corresponding pairs of angles, the triangles are similar. Our similarity statement goes as this. Triangle CDE is similar to triangle ABE. Now, because these two triangles are similar, their corresponding sides are proportionate to each other. Now, we may write our proportions. So, because these two triangles are similar, we know that DC is equal to AB. So we set it up like this. Now, our other sides are CE equals AE. The other side we have is DE over BE. Now we can fill in what we know. So for DC and AB, we are not given any knowns, so that will not help us in finding side CE or X. We do have knowns for CE over AE. CE is X and AE is 12. We also have knowns for DE and BE. DE is 8 and BE is 24. Now we just cross multiply. So 24x equals 12 times 8, which is 96. Divide by 24 to isolate x. X equals 4.